Welcome! In this series of videos, we will look at software add-ons for both the PowerBasic console and Windows compilers. Today we'll look at SQL Tools, an add-on from Perfict Sync software, and running SQL queries through a generic function. Following on from the last video on SQL Tools, where we connected to a SQL Server database, ran a query, and obtained back a record set of data. We want now to encapsulate that code in a common function. We'll put that function into our generic SQL library to allow us to run almost any query against a SQL Server database. In this series of videos, we'll be covering topics which are common to both the PowerBasic Windows compiler and the PowerBasic console compiler. In order to do this, I've set up a small common library to allow us to display information on the screen from our program regardless of whether you're using the Windows or the console compiler. There are three basic functions in this common display library. There's prep output, log, and wait. In our last video, we used the SQL Tools library to enable our PowerBasic application to run a query against a SQL Server database and return the results. What we're going to do today is to create a generic function which can be used to run a query against a database and return the data in an array. As in the previous video, we will be using the Pro version of SQL Tools, and we will be connecting to a SQL Server database. So in our code, what we did in the last video was we made a call to the fun process function. And this was the function we used to connect to our database. Currently in the fun process function, there is an embedded piece of SQL. The first thing to do is to remove the SQL from the function. We're going to populate a variable called strSQL before we call our generic function. So we will just prepare a variable we can use. And what we're going to do now is we're going to call a generic function. So we're going to comment this piece of code out. And we're going to create a generic function to perform all the database activity. So what's this function going to take as parameters? Well, we'll need to give it the SQL we wish to run. We're going to be giving it an array which we want the generic function to populate, which will contain the data. We need to give it the handle of the database. We want to give it a status variable where it can pass back any errors, and we'll want to give it a statement number. So there's some things we'll need to set up before we call this function. So we're dimensioning an array as a string array, and this gets passed to the function. We will want to specify our statement number. In this case, this is our first statement, so we'll mark it as statement number 1. Now, the idea with this common function is it will return a true or a false. If it returns false, then the function has been unsuccessful. So, as we did before, we will output to our log the fact that the processing has actually failed with the error message. If the function succeeds, we will have a populated array, and we can then display that data on our log. So let's create that generic function based heavily on our fun process function. We'll just copy that entire function, and we're going to paste that in to our generic library. And we're going to call that function get generic SQL data. Now the parameters we want to actually pass into it, we have here. So the first parameter we're passing is the SQL, which which is a string. The second parameter, we're going to do a by ref on this one, so that we're passing basically a pointer to where the area in memory where the data is going to be held. Our fooddb we will pass as a variable. Longdb, the status again is a string, and our statement we're going to make optional. Now we don't have to declare the SQL because it's been passed as a parameter, so we can remove that. But we will need one additional parameter. We're first of all going to check that we have actually been given long statement when the function was called. So we can test that using the isMissing command. And we will use a new variable to populate. So if the statement has not been passed, then we'll default to number 1. Otherwise, we will take the value we're given. So having done that, we can remove the hard coding we have in here for the SQL because it's being passed as one of the parameters. Now we have hard coded in here both the database and the statement numbers. So since we're passing them as parameters, we can remove those two quite happily. And every reference subsequent to this that's actually referring to these two pieces of information, we can replace with the variables that come in on the parameter list. And the final one to do should be when we close down the statement. There we are. All we've done is a quick substitution of the hard coding with the values we're bringing in. Now to look over the statement we did before, the first part, the SQL statement function, is actually used to parse the statement. Now if that's successful, then we begin a loop until we get to the end of the data. We're fetching the result, and if that's successful, we are picking up the number of columns. Now at this point, we know we have at least one piece of data. And what we need to do is, since our plan is to put that data into the array, we're going to redimension the array with the preserve option to make sure any information in the array remains. And we are redimensioning the array to make it one element larger than it was previously. So initially the upper bounding of the array would be -1. So the first pass through here would make the array 0. And this is ideal for storing our headers. We're storing the headers as in the column names in the SQL info variable, and we're storing the data in the value variable. And then for each column, we're actually picking up the value of each of those columns to put into that variable, so they effectively accumulate. And by the time we get to the end of the columns, so if there are 5 columns, after the 5th column we would then trim off the trailing pipe delimited characters. Now I've chosen the pipe delimiter quite deliberately, as in most cases you are not likely to have the pipe character in your data. Using a delimiter of something like a comma or a tab would not be a good idea, because in many cases tabs, commas, quotes all tend to sit inside SQL data many times. So once we get past that piece of code, we're testing here and we were outputting to our log what the column headers were. Now we don't want to put anything to log at this point, but what we do want to do is we want to store errors. And we can do that by another readin command to ensure that the array goes up by another 1. So the first time we actually run through this, we will get to this line of code. We will already have dimensioned the array as 0 in elements. This will redimension it again to make it 1. And after this, we can then store the column names in the 0 element of the array, because long will count and the moment is still 0. After that, we increment long count, and we were outputting our data to the log. Now we don't want to output the data to the log. What we want to do now is store that data in the array. And str value holds that information, so we're storing that using row count, which has been incremented in this case to 1. Now after that are the else conditions. So if there's no data, then we basically put no data into the str status variable. Now at this point the array will not have been redimensioned, so the array will still be empty. So let's try a compile on that, just to see we have not missed anything. Indeed we haven't. So we try running that now. But first, let's have a quick look at the SQL to remind ourselves what we should be getting from this. There is our select statement, and if we remove the top 1000, there are only 4 records in here, so top 1000 is a bit overkill. We can actually run that, pulling back the information from our table and getting back 4 rows of data. The column headers, the index numbers, and the food type. So if the generic SQL data function actually performs as expected, we should get down to this line of code. So at this point we would want to output this to a log so we can see that we've actually successfully received data, so we can see we've successfully received data within the array. So all we're doing here is a simple for next loop, stepping through each element in the array from 0 up to the upper bounding of the array and outputting whatever we find within the array itself. So as we're using a new variable, we will just declare that one as well, and we'll attempt to run our code. And there is our data. We're opening the database successfully, we're pulling back the headers from the 0 element of the array, and we're pulling back 4 lines of data, 1 for each of the items. So what we've done is we've created a generic function to pull back SQL data. Now to prove this will function for any piece of SQL, all we need to do is to change our SQL, but not change the program. So we're going to run a query on the food items table now. Now the food items table is a larger table. If we select the data from that, we'll see this one actually has 153 rows. Now what we're going to do here is we want to count how many items of each type of food there are. So we're going to put a count function in. And we're going to group on that. So that gives us the items and the total number of entries for each item. Now let's do an order by to do a little bit more processing on it. And we're ordering by the total number, and we want to do a descending one to see which are the most common. Now if we're just interested in example the top 5, we'll put top 5 in, and there are our 5 items. Now that's a completely different piece of SQL. Let's take that piece of SQL for which we know the expected outcome, and we will create a new query based on that SQL. It's important to put a space at the end of each of these lines so that SQL itself doesn't get confused when you jam two lines together. So there we have a new piece of SQL. We'll just comment out the old. And if we run that now without changing our code at all, this SQL will be passed to the generic routine and we should get some data coming back. So let's try that now. And there is our data coming back as expected. We're getting the two column headers, food item name and total. We're getting an entry for each of the 5 food types we're looking for and a count showing the number of items for each. What we've done is to create a generic function which can be used to call the SQL Tools library to get back the data you're looking for without having to do a lot of coding. This is a very generic piece of code. It may not be suitable for all of your queries, but it will do for a great number and should cut down the amount of coding you actually have to do. One thing you can do with the professional version of SQL Tools is you can call stored procedures. So let's have a look at a stored procedure. The query we've already run gets us back some data. Now let's change that to the top 6 items. And what we'll do now is we'll copy this entire piece of code and we'll go into store procedures and we will create a new store procedure and we will replace from the template for the SQL we're looking to run. And we're going to give this store procedure a name. And we'll call it get test data. Now in this particular case, this store procedure doesn't require any parameters, but what we'll do is we will execute that and it should create our store procedure. We'll refresh our list and we should see down at the bottom we have a new store procedure called get test data, which returns data but requires no parameters. So if we try running that on its own, we get back the data we want, and all we need to do is run the call to the store procedure. So with the professional version of SQL Tools, what we can do is we can take this string of data, we can replace our SQL with that. So if we comment out the previous SQL, all we're doing now is we're calling the store procedure. Now you don't actually need the exec in front of the name of the store procedure, but I like to put it in for documentation purposes since it makes it much easier to find store procedures within your code. Now if we run that now, we get back the 6 items we asked for. So we know we're definitely running the store procedure because the previous SQL code only brought back 5. So the beauty of doing SQL queries in store procedures is twofold. First of all, it makes the code within your application much tidier. It means that if you need to change a query, then it can be done entirely in the database and doesn't have to mean a change to your PowerBasic code. Now, having got your data back, what we're doing here is a simple dumping out to the log. If you wanted to pull back a single column from that array, so we can use the parse command to pull back part of the information that come back from the database. Say for example we wanted to actually pull out just the name of the item as opposed to the number. The parse command is very powerful and it can be used, since we know the delimiter of the string, to pull back the first element, which in this case is the name. So if we run that now, we would get just the names. What we've seen today is you can actually create a generic function to call your SQL Tools library. Now while this function won't be able to actually do all of your SQL calls, it could handle quite a number. And for those other specific calls, we can create new generic functions to handle those as well. But that's it for today. Thank you for watching.